Hey everyone, welcome back to the series. In video 1, we talked about why traditional data lakes started breaking at scale. And in video 2, we walked through how to pick the right tech stack for your lakehouse. If you have not watched them yet, link to both the videos is in the description. In this video, we will actually build it. No more slides, just a terminal. And by the end of this video, you'll have a fully working local Spark environment in your machine. Spark connected to AWS Glue as an Iceberg catalog, a real Iceberg table created and visible in both Glue and S3. You can find all the steps that I will execute in the repo given in the description. So let's get right into it. Before proceeding further, a quick recap of what we are actually building. This is the same architecture we designed last video. Spark writes, Trino reads, both talk to the same AWS Glue catalog, and they are querying the same Iceberg tables which is stored in AWS S3. Now this is the multi-engine setup we discussed in video 2, where Iceberg's open format means you are not logged into a single engine. No copies, no sync, same table can be accessed by different engines. Okay, so let's set it up. For this, we need the AWS CLI installed and pointed at an AWS account. For users on Mac, you can all follow along. For users on a Windows machine or Linux, I will provide the steps in the repo. On Mac, we will be using Brew to install our AWS CLI. I have already installed it and it's the latest version. You can also check the version running AWS hyphen version and you should see something like 2.xx. And if you are on a lower version, I suggest that you upgrade it to the latest ones to make sure that nothing is breaking when we are running the other commands. And for the whole setup, you will need an AWS account which has the permissions to create IAM resources. And if you are using a personal account, your root or admin user is fine for this tutorial. If you are in a company account, check with your AWS admin. You will need IAM write access, which is often restricted. And for this tutorial, rather than using our default AWS profile, we'll use a named profile to keep our tutorial credentials isolated from anything else you might have configured. And to create the profile, we'll just use this command. And here you will be prompted for your access key ID, your secret access key, your default region, and your format. And now use the US East one unless you have a strong region to use another region. Some of the S3 APIs quirks we will hit later are slightly different outside US East one. So for this tutorial, just to follow along, you can use US East one as your region. And just to make sure that our profile is correctly configured, we'll just call AWS STS get caller identity API, and if you are getting your user ID account and ARN, that means that your credentials are valid, and everything from here will now will use this profile that we have created. Okay, so now that this is out of the way, let's set up some IAM policy. Okay, so first create a policy document. I have already created it, and the JSON that you see here, I have put it in the repo too, so you can just copy paste it and attach it. Okay, and I want to be very clear about this, and I mentioned it in the previous video too. This is tutorial only. In production, you'd scope every action down to specific S3 prefixes and specific glue resources. Here I am being deliberate about which actions we actually need rather than just handing out full access, but the resources are still broad for simplicity. So okay, so once you have the saved, just save this JSON, and now using this JSON we'll create a policy. So to create the policy, we'll call IAM create policy API. Just give the profile name and attach that policy document. So once that is done, you will get something like this. Okay, and just keep this ARN handy. This will be used in further steps as well. Okay, now we will be creating a IAM group named Iceberg tutorial group, so that similar users can, if we need to create similar users, they can all be attached to the same group, and this group will have the policy that we put earlier. Okay, so now let's just attach that policy to this group. So here if you see, I am using the group name that we created and the policy ARN that we copied from the above command. Okay, so let's just press enter, and policy is attached to that group. And now we will create a user too, which is nothing but Iceberg tutorial user. Once that is done, we'll just add this user to the group, okay, and that we will do using add user to the group API. Okay, so once that is done, now we have our IAM roles done. Okay, and now the next step is for us to for the user that we created, and to access S3 we'll need that access key and secret key for this user. Okay, so we will use the create access key API. So I'll just pause. So you just press enter. I'll pause it here. I don't, these are credentials, I don't want to share it. So once you press enter, you will get that access key and secret access key. Save those secret as they are shown exactly once, and please make sure that you are not sharing them with anybody. Alright, now that we have the access key ID and secret access key, now let's create a Glue IAM role. Okay, so Glue needs its own IAM role. This is what Glue assumes when it runs compaction and maintenance job on our Iceberg tables. Don't worry about what compaction and maintenance jobs are. We will discuss them in detail in some separate video. For now, just create another JSON file called Glue Trust Policy, and just add this JSON to that file. Again, this JSON is present in the repo too. So once that is done, what we will need to do is we need to create a role and attach that policy document to that role, and we will attach that policy to our Glue role. Okay, and this is the same policy that we created above. Okay, so now that role that we created has the policy, and the next step for us is to just attach the role policy. Now this last one that we are doing, it's only for your AWS managed Glue, and it covers things like your CloudWatch logging that Glue needs internally. Okay, so so that is done. So now we have set up everything in our for our IAM. Next step would be to create our S3 bucket. Okay, now that our IAM roles are done and IAM user is created, now let's get into the S3 bucket creation. For the S3 bucket creation, again, we'll just use the same command line. So just use the create bucket API and give your bucket name. So this bucket name needs to be unique across your account. And here, if you see, I'm using the region US East 1. Now, if you are not using the same region as East 1, so what you need to do is you need to add another constraint, which is this one. So create bucket configuration and the location constraint, and just add your location. Since I'll be using US East 1, I don't need to do it, but I have added this detail into the repo. Okay, so let's just create this bucket. Now two more things to be done before we move on. Both of these should always run right after creating any bucket. First is to block any public access. New buckets created via the CLI don't have this enabled automatically. All four flags explicitly to be set. So again, we'll just set up public ACLs, ignore public ACLs, block public policy, restrict public buckets. So we'll just put that to our S3 bucket so that it's secure. Next thing that we need to do is we need to make sure that the data that we are putting into our S3 bucket is encrypted. For that, we'll just use this command. Okay, this is nothing but bucket in. We have just put the bucket encryption. Now SS3 S3 is fine for this tutorial. If in production you'd use SSE KMS with a customer managed key, so you get key rotation and cloud trail audit logs on every access. Alright, so let's just verify all the three steps that we did. Okay, so perfect, our bucket is created. Now let's just verify whether the public access is blocked or not. Perfect, so all the public access is blocked, and let's just check the encryption too. Okay, perfect. Encryption is also enabled. All right. After doing this, the next step is to create a Glue database. If you are new to Glue, I'll do a dedicated deep dive on the catalog layer later in the series. We actually touched on it why catalog choice matters in video 2, but again I'll do a dedicated deep dive into the catalog choice as well. Okay, so let's just create our database. So here I'll use the create database command and give it the name Iceberg tutorial, and this is important. So this is the path, this is the S3 bucket that we created, and we are just adding another path of slash warehouse. Now slash warehouse is not mandatory, but it's a it's a community standard that is used when we are working with Glue and Iceberg. Okay, so let's just create the database and let's just verify that the database is created. Okay, perfect. So as you can see, the database is created, and now that's AWS side done. Everything from here is the local setup. All right. So on the local setup, we need to install Java, Python, and Spark. And again, I am on MacBook, and I'll note where Windows steps differ. In the repo, I have added separate steps for Windows. I could not test them, so let me know if you encounter any issues. All right. So let's start with Java first. Okay, and for this setup we will be installing Java version 17. Now different versions of Java are needed for different versions of your Spark. All right, so Java 17 and I'll be installing Java Spark 3.5.6, and both are compatible. And the similar thing we need to do with Python as well, and Python needs to be 3.11 for our Spark 3.5.6. Alright, so please make sure that you are installing the correct versions, otherwise you will encounter into some problems which will need some debugging. Okay, so perfect. So once this is done, what we need to do is we need to create the system symlink for our system to access the installed Java version as the default one. Okay, so just create it, give your password. Okay, and we are done. Now another thing that we need to do is we need to update our .zshrc file. Okay, so this is the file, as you might be aware, is loaded every time we open a new terminal session. Okay, so just copy paste these commands. Again, everything is there in the repo, so you can just copy paste it from there. Okay, so let's just source the ZSHRC file and just verify the Java version. Okay, perfect. So we have OpenJDK version 17.0.19 running, and that's all for the Java installation. Now we will install Python 3.11. Installing Python 3.11 is very easy. Just do brew install python @3.11 and it will download it. Okay, again for Python as well, we need to create some local symlinks, so Python 3 resolves to 3.11 specifically. Okay, because there might be some other Python versions you might have already installed. Let's just wait for it to be finished. All right, perfect. So first I'll create a local .local/bin directory, and then again I'll create some links for Python 3 and specifically for pip3. Okay, now again the same thing that we need to do with respect to our ZSHRC again. Okay, open it again. We'll just need to add that local path to our ZSHRC file, and you can just add it at the beginning here and just save this. Again, the next steps, as we did earlier, just source the ZSHRC file, just verify that everything is fine. Okay, so Java version is fine. Same thing we will do with Python version. Oh, sorry, Python 3 version. Okay, 3.11.15. This is perfect. Okay, so now that Java and Python are installed, let's install Spark 3.5.6. Okay, so what I do is I create a tools folder and a tools/script folder, and I'll place my I'll just download my the Spark zip file there. This helps me in maintaining different paths, okay, and scripts file is needed so that it just helps me in maintaining different versions of Spark if I need to be, if I need them running in my local. I'll just, in the scripts, I'll just create a small shell script which will be loaded every time I run my Spark, and it will just make sure that the correct Java and correct Python versions and correct AWS things are loaded every time we run the Spark. So this one is bit big, and it will take some time, so let's just wait for that. All right, so once you have downloaded this zip, the next step is for us to unzip it. Once that is done, we can just, we'll move this Spark 3.5 bin Hadoop 3 to simply Spark 3.5.6 for the sake of simplicity, and we will remove the zip that we downloaded. Okay, now you can, before going further, we can just verify that our Spark is installed or not. Okay, perfect. As you can see, Spark version is installed, and again this command you will find it in the repo. Okay, so once that is done, as I was saying earlier, let's create a Spark activation script, and this is just a small shell script. What it does is it loads your required environment variables, and it helps us in, rather than polluting your global shell environment, we just specify it to this particular Spark shell script. Okay, so so let me just show you what I have done here is, so I have added Spark home, PySpark Python, PySpark Python path, and the path, and then I'm just loading the Spark submit. Okay, so once this is done, we'll just need to make this shell script executable. Once that is done, let's just source this just to make sure that this is running fine. Okay, so now next time we don't need to, we'll just simply source this file and run our PySpark. Okay, so now we have everything installed. Okay, Spark is fully operational, and you can verify it as well. Just run the PySpark command, and here you are in the PySpark session. Okay, so your Spark at this point is up and running, but still it has no idea about AWS Glue or Iceberg, and that's what we will cover next. Okay, now this is the most important section. There are three things Spark needs to talk to Glue: credentials, jars, and configuration. Okay, so first we will start with AWS CLI and the credentials. If you followed the prerequisite sections, the CLI is already installed and your Iceberg tutorial profile is configured. Okay, we can just do a quick end-to-end verify before we go further. So using this profile, let's just get the databases, and here if you can see, we have already created this database which will write the data to this particular S3 path. Okay, now next step is for us to download the Iceberg jars. Okay, so Iceberg need two jars. One is Spark Iceberg and one is Iceberg AWS. So Spark needs a jar to connect to write Iceberg related APIs, and Iceberg AWS bundle or a jar is also required to talk to so that Glue and Iceberg can also talk and the metadata layer can be maintained. Okay, so for the same, what we will do is we'll simply create a jars folder and move to that jars folder. So here we will need to download two jars. So this is first Iceberg Spark runtime jar, right? It is for 40 megabytes, so I think it should be finished in just a couple of seconds. The next one is a bit bigger, that is our AWS Iceberg bundle. Once that is done, so this is the Iceberg AWS bundle which our Glue catalog will need. Okay, so let's just get the two. This one is also 47 megabytes, so it should be done quickly. Right, and once this is done, we'll just verify both the jars. that they are perfectly lying in our jars folder. Okay, yeah, both the jars are here. So next thing that we need to do is we need to, rather than passing the configuration flags every time we start Spark, we configure the catalog once here. Okay, every Spark session, PySpark, Spark Shell, Spark Submit will pick this up automatically. Okay, so for that, what we need to do is so there is a spark.conf template. We'll just copy it and create a Spark defaults. Okay, .conf, and just open this. Okay, at the bottom, if you go to the bottom, okay, so at the bottom, just add the following lines there. Okay, and all of these lines again are present in the repos, so you can copy it from there. Okay, so they are nothing but here we have given it what the glue catalog is. Okay, what is the warehouse path, which is the default catalog, what is the region, and what are those jars that we needed. Okay, so just once that is done, just save it, and your Spark will automatically pick it up. Okay, now the next thing that we need to do is we need to update our Spark shell script that we had earlier. Okay, and here we need to provide the AWS credentials too, so that our Spark can pick it up. Okay, so let me just copy it. So what I'll do is I'll just copy it here. Okay, so I'll just remove these lines. They were just similar lines, some print commands. Okay, so once that is done, now one thing I want to call out here in this script is that I am exporting both AWS default region and AWS region. AWS default region is what the AWS CLI and Boto 3 use, but the Iceberg AWS bundle, which uses AWS Java SDK v2, specifically look for AWS region. Okay, I hit this up when I was doing my setup, and the message was also not obvious, so I just want to make sure that you have both the paths configured. Okay, so let's just source this command again, source this shell script again, and if you see, perfect, our Spark is up and running. Okay, now what we can do is we'll just verify whether the glue setup and the connection to the glue Iceberg catalog is done or not. So for that, what we'll do is spark.sql show databases. Here it's simply a plain SQL command, and that's what we use to talk to our glue. Okay, our Iceberg table, sorry, not glue. Okay, perfect. As you can see, the database that we created, it exists. Another thing that we can do is, let me just copy this. So currently there should be no table in this particular database. Okay, so perfect. As you can see, no table is created, and so what this means is you are connected. So your local Spark is talking to real AWS catalog over the network with Iceberg ready to go. Okay, so we have done the setup. Next step would be to create an Iceberg table. Okay, and this is where the architecture that we discussed starts becoming concrete. Okay, we'll use a users table as the example, very straightforward again. Okay, so here just change that database name, and this is the user that we are creating from Spark. Now you can create the same user from AWS CLI as well as from the console. Okay, but from this Spark session we are just creating some table names, and here if you see, this is the interesting part. Here we have specified that we want this table to be created in the Iceberg table format. Okay, this is what tell our glue that, and to make sure that the table is in the Iceberg table format, and all the metadata and all the data is set up accordingly. Okay, and this is interesting. This is the S3 path that we have set up. Okay, and here if you see the table type Iceberg format, we want our data files to be in a Parquet, and this is just a compression how we want, and these two are important. So here if you see that this is the metadata cleanup settings. Okay, what it means is that we want to prevent our metadata files accumulating in S3 over time. This is the kind of thing that bites you months later in production if you don't set it early, and this is very similar to this the tiny file problems that we talked about in video 2. This is the metadata equivalent, Iceberg metadata equivalent of that. So let's get this out of the way, and we will have our table created. Perfect. Okay, so now let's just see whether our table is created or not. Yeah, so let's just run this command. Earlier it showed that there is no table. Perfect. Now you can see we have this namespace and we have the table name that we created. The table exists, and if you have followed me till now, I just want to congratulate you. This is the this is your first Iceberg table that you have created in this tutorial, and that's the full local setup. You have Spark, you have Glue and Iceberg all connected and working, right? So just pat yourself on the back if you followed along, and if you have set this up. Okay. Just to recap what we built today, we did the AWS IAM S3 and Glue configuration all from the terminal. We installed Java 17, Python 3.11 and Spark 3.5.6 on our local, and they are running everything running fine. Then we connected a Spark to the AWS Glue as an Iceberg catalog via the Spark defaults configuration. We created an Iceberg table, and now you will notice that we haven't touched Trino yet. That's intentional. Trino deserves its own video. And in the next video, we'll install Trino locally, fire it up to the same Glue catalog and query the exact tables we just created. Okay, no copies, no sync, same Iceberg tables, just different engine. And that's the multi-engine promise from video 2 becoming real. After that, we go deeper into Iceberg internals, the snapshots, the manifest files, and what actually happens on disk every time you write data. Okay, so if you're not subscribed yet, do that now. The next video is where things start actually getting really interesting. Okay, drop any questions in the comments and I'll get back to you. See you in the next one.